Now for the second part of the experiment, we're going to react the crystal violet solution with a solution of sodium hydroxide. And we're going to measure how the absorbance changes over time. This is going to tell us the order of the crystal violet. Is it zero order, first order, or second order? So in order to do this, I'm going to take 10 milliliters of the stock solution of crystal violet, and I'm going to react it with 10 milliliters of 0.02 molar sodium hydroxide. Now, 0.02 molar is 1,000 times more concentrated than the 25 micromolar of the crystal violet. And that's important. By making the sodium hydroxide solution so much more concentrated than the crystal violet, what we're essentially doing is keeping the concentration of the sodium hydroxide solution constant over the course of the reaction. And this allows us to determine the rate of just the crystal violet. So that's why in this lab, it's going to ask you to solve for a pseudo rate law. It's not the true rate law because we're not going to figure out the order of the sodium hydroxide. We're essentially keeping that constant by adding it in such a large excess. But we are going to be able to determine if the crystal violet, again, is zero order, first order, or second order. So what I'm going to do is I've already recalibrated my spectrophotometer. Instead of using just a blank with just water, I used a blank that's half water, half sodium hydroxide solution. The point of that is to, again, zero out any absorbance from the sodium hydroxide solution. So I'm going to measure out, still using my serological pipettes, 10 milliliters of each solution. I'm going to stir and then quickly get them into a cuvette so that I can start measuring. You do want to move fairly quickly here once you mix them together, because we want to try to get our absorbance data as close to time zero when the initial reaction started as we can. So I'm going to get my Logger Pro set up here. So for the Logger Pro, let's move this out of the way. We did absorbance versus wavelength. Remember, this was to determine what the optimal wavelength would be for the crystal violet. And then we also did absorbance versus concentration so that we could make a calibration curve. Now what I want is I want to pick absorbance versus time. I'm still going to pick the same wavelength that I used earlier because we already determined that that's a good wavelength to measure the crystal violet at. But I want to pick the versus time. So I'm going to hit OK. And then I'm also going to go up here to experiment and data collection. So I'm going to let this run for 20 minutes. I want continuous data collection, and I'm going to take 3 measurements every minute. So I hit done. So now what I'm going to do is I'm going to get my reaction started. I'm going to measure out the 2 solutions, get them into the cuvette, and then we will be hitting the collect button. So what you should be noticing from the data here is that as the reaction time progresses, we see the absorbance decrease. Again, that's because the crystal violet is being converted into a colorless product. So the colorless product is not going to be absorbing light. We're going to let this go for 20 minutes. So far it's only gone for 5 minutes. We're going to let it go for 20 minutes, and then we will hit stop for the collection. And then we're going to export this data into Excel so that we can manipulate the absorbance data to figure out, is it zero order, first order, or second order?